Let us take a look in this first lesson at getting used to some of the features of the lesson and of our TI-Nspire calculators. What we have done in our tutorials and our guide here is always show you how to manually work out problems. Then next we show you how to work the problem using our calculator. If it works on the TI-Nspire numerical calculator and works on the TI-Nspire CAS computer algebra system calculator, we will label this as family. When we label family, this will mean that everything works, or parts of what we're showing work on both calculators. So if we go over here to our calculator, go to the home key, and go to current, we will see that inside the calculator is the same information that is displayed over here. So the one really nice feature of the calculator is that we have pretty input, and that the calculator will do the order of operations for us. When we're looking at the order of operations, what we want to do is simplify all operations with inside any grouping symbol, simplify all operations above or below a fraction symbol, start with the innermost grouping symbol. They use this mnemonic for simplifying expressions, this acronym. So the P stands for parentheses, which is this information right here. The next thing is, after we get done with our parentheses, we want to take a look at exponents. So simplify all exponential expressions. The next level is to perform multiplication and division. Then we need to perform addition and subtraction. In 3 and 4, we want to go from left to right. So it doesn't mean do multiplication over division. It means these are both performed at the same level and perform them from left to right. And the same thing with add and subtract. Doesn't mean that addition needs to be performed for subtraction. It's whichever one occurs from left to right. Now the last step here, is it listed up here, is simplifying any unary operations. So what we mean by a unary operation is an operation like absolute value, or an operation like square root, where only one number is involved. Going back to this particular problem, we see here that we have parentheses, so we add the two. Then we have multiplication, subtraction, multiplication. So the two multiplications need to be done first. So we get 14 to 3. Then we need to work above the fraction bar. So this turns out to be 11. Then down here we have addition and exponents. So the two exponents need to be done first, 49 and 1. Then we do the addition and end up with 11 over 50, which is the same answer that we got when we used our particular calculator. Okay, let's go back to the first part of this chapter and start from there. We will start off with exponents. So to show what's going on, we like to use the Scratchpad area. Now, this tutorial is built for using both iPads and handhelds, for using both members of the family, whether they be the numeric CX version or whether they be the computer algebra system version. So people using an iPad will need to simulate the Scratchpad by opening a document and not saving it. Okay, so we're going to go over to our calculator. We're going to switch to the Scratchpad area. The Scratchpad area had, again, our introductory lesson of multiplying numbers out. So we need to clear this out. So if we go to Menu, and then we go to Actions, which is number 1. Okay, oops, I didn't mean to do that. So let's get rid of this word define. again, clearing out the Scratchpad is something that we do a lot. Since we do it a lot, I have into my head just to press menu 1 and 5. But since you're just getting used to this, you do not know those commands automatically in your head. And so earlier, I made the mistake of pressing the wrong stuff. So let's go through it again. Okay, so we press the menu. We need actions, okay, which is going to be option number 1. Then we need number 5, which is to clear the history. So up here it says 5, clear history. Now we prefer just to go ahead and hit the numbers on the numeric pad. So this clears out this. Now at this point we can do exactly what's shown over here. So we can put in 10. We want to raise it to an exponent power, so we're going to use the caret. Raise it to the 9th power and press enter. Then to show 10 to the 3rd, we're going to put in 10. Raise it to the 3rd power, press enter. To show division, which is actually going to turn out to be subtraction, okay, of exponents, we're going to put in, well, we can do it with the division, or we can use a template. With math input being pretty, templates are a nice technique to use. So we can click over here with our control. It will give us the numerator. So we put in 10, raise it to the 9th power, use our arrows to move down, put in 10, raise it to the 3rd power, press enter, and see that the answer turns out to be 3 zeros and then 3 more zeros. So this is going to turn out to be 1 million. To show that this is 6 tens, we type in 10 times itself 6 times. One, two, three, 4. Need 2 more. And we can see we end up with the same answer. So we can use our Scratchpad and working out information to come up with rules. Flipping ahead to the next page, we come up with a definition for our exponent notation. In our tutorials, when we have definition, we will write these in this burgundy color. Then we will have examples, which we will show you how to do manually and how to do on the calculator. Then after you work this out, we will follow with an exercise, which you use this interactive link to check your work. We show the exercises using iPad screens, and we give directions in our tutorials for both using the handheld and the iPad. So 2 to the 5th power is 32. 4 to the 3rd power is 64. So we're showing one of these as being multiplied out and one of these using exponent form. Let's go ahead and click on this link. So when we click on this link, you will see some partial parts of the iPad screens for working problems out. And over here on the iPad screen, we also illustrate the precedence order, which we were talking about earlier in our lesson. So when you have a problem like -2 to the 4th power, the answer turns out to be 16. -2 to the 3rd power, the answer turns out to be -8. Well, what do we do in the situation where we have the opposite of 2 to the 4th? This is not -2 to the 4th as this problem. This precedence order says exponents get done first, So 2 times 4 is 16. And then we take the opposite, which would be a unary operation, and end up with minus 16. This becomes really confusing because when we're doing an odd exponent, we always get the correct answer. But when we're doing an even exponent, these two problems have different answers because of the precedence rule. Then we press our return, and we return us to where we were. When we have expressions with add and multiply, there again can be two different ways to work the problem. So again, let's take a look at our Scratchpad. So we'll go over to here, and again, like I said, if we'll go through it manually here, menu, 1, and then 5, we'll clear the history. And again, you'll become very proficient at going menu 1, 5 to clear out your Scratchpad's history. So if we put them into our calculator will do the natural precedence order for this particular problem. So the natural precedence order is to do the multiplication first and then do the addition. So this is going to be 8 plus 3, which is going to turn out to be 11. To show other ways to work the problem, to show that what would happen if we wanted to do the addition first, we'd have to put in a grouping symbol. So when we go to our calculator, put in a grouping symbol. Now the nice thing about our calculator is it automatically puts in both the beginning and the end of the grouping symbol. So we can just move over to have it actuated and then take it times 2. So we want to show the times and the 2. So if we're looking at this, parentheses is going to be done first. So 7 times 2 is going to turn out to be 14. Now, let's say if we wanted to emphasize that the multiplication was done first, we would put in 3 plus parentheses and then 4 times 2. Now, what happens is we do not have to get on the other side of the parentheses to implement the closed parentheses. We can just press enter. The other thing that's going to happen to us is this parenthesis is not necessary. So when we press enter, notice that it's dropped. Again, this is the calculator always goes to this mode where even though we enter things in one form, if it can write it in a simple form, it will do this automatically. So that's what we wanted to illustrate here. Moving forward a couple pages, we see that we have how our real numbers are organized. Starting off with the natural numbers, 1, 2, 3, also referred to as the counting numbers. When we add 0 to this, can anybody tell me what the Roman numeral symbol is for 0? When you take a look at Roman numerals, when you hit 10, they come up with the new symbol X. When you hit 100, they come up with a new symbol C. When you hit 1,000, they come up with a new symbol M. So 0 is not as easy as you think. So again, us adding 0, we come up with the whole numbers. You can kind of maybe visualize this concept by how much Coke is in an empty bottle. When we take the opposite of the natural numbers, combine that with 0 and the opposite, we end up with the integers. So we go out this way forever, minus 1, 0, 1, 2, 3, because this includes everything within inside here. Then the next set of numbers we end up with are the rational numbers, which are composed of 2 integers written with the numerator and denominator. Now, for this notation, we can use decimals, we can use mixed numbers. The 2 decimals have where it can terminate or where it can repeat with the pattern. Now, what can be confusing is a changing pattern. So if the pattern continually repeats, like 777, it's a rational number. But if the pattern changes or there's no pattern, it's what they call the not rational. The prefix IR means not, or irrational numbers. Again, let's take a look to see what's going on with our calculator. So we'll go over to here, menu, 1, 5, to clear it out. Then we'll want to type in E. So we click this key right here. It wants an exponent for this, and we press enter. Look at the difference between what's displayed here on the Scratchpad and what's displayed over here. When you're dealing with the CAS model, it likes to keep everything in exact form. When you're dealing with the non-CAS model, it likes to put things, it puts things in numerical form. So this number E is a number that we'll talk about later in our algebra lessons, and we'll cover it more in detail. To get the same effect on the CAS model, there is an approximant above the E, which is in blue. So if we go up to here and press enter to transfer it down and press Control Enter, we will see that we get the same numerical expression that we got over here. The same thing happens for pi in the square root of 2. So if we press pi and press enter, we will see that we get pi. To get pi written as a decimal, we can copy it by going up with our arrows, or we can just hit pi again, bring it up from our template, and press Control Enter to get the answer to be 3.14159. To deal with square roots, notice that it's in blue, so if we press Control and X squared, we see the square root symbol. Then if we press 2 and press enter, notice again our CAS model keeps it in exact form. To actually see the answer, again, let's copy it down and then press Control Enter, and we get the numerical value. Moving ahead a couple pages, one of the hardest things is to switch a repeating decimal over to its fractional form. And we're going to use the property of equalities, where we add the same thing to both sides, or we multiply both sides by the same number. Now, technically, in the next unit, we deal with sign numbers, so adding a negative would be the same as subtracting, and multiplying by a reciprocal would be the same as dividing. So we find it easier in our example here to actually use the dividing in here and subtracting than to use the adding a negative and multiplying by the reciprocal. Okay, so let's go ahead and work out the most complex of one of these types of problems. We can see that it starts repeating with the 3, 7, but it does not repeat right at the decimal point. So to get the repeating, the trick is to get the repeating part to be to the right of the decimal. So we'll start off with our original expression and we'll multiply it by 10 to get the repeating part to be to the right of the decimal. Then the next trick is to get rid of the to get the number of repeating decimal places here to multiply by that. So there's 2 repeating places, so we're going to multiply by 100. If there was 1 repeating, we'd multiply by 10. If there was 3 repeating, we'd multiply by 1,000. So we're going to take this number here and multiply it times 100 and get the repeating part to be all over here. Then we have 2 equivalent ones, so we're going to subtract these from each other to get that 990x is equal to 1225. So we got rid of all the repeating part. Then we're going to divide both sides by 990 and reduce it. What we do is we use the Scratchpad to illustrate stuff, but we use the examples to keep things in our calculator. So to take a look at this, if we go to the home screen, and if we go to current and take a look at what's shown, we opened up our examples from chapter 1. So the second example had to do with the order of operations, which is how we begin our lesson. We need to take a look at example 3. To move between tabs on your calculator, we will press Control, and it will show us the calculations that are involved here. So one of the things we can use our calculator for is the traditional calculator calculations. So here we end up subtracting 10 and getting 990. We end up just taking our 1225 and then dividing it by 990 by using either divide or using the template, and then the calculator will automatically reduce this for us to 245 over 198. The other thing that happens is, again, if we want to make sure we did our work right, we can take this number and bring it down and press Control Enter to see that we have our original repeating pattern. Again, this kind of problem is usually difficult for people, so armed with how to handle where the thing repeats not directly at the decimal but over is our first step, and then armed with how to many digits repeat to come up with an equivalent equation, then subtracting these two, we can come up with a way to transfer a repeating decimal into its fraction. What we do with our real numbers is represent them on a number line. So number 5 will be 5 marks over. Number 0 will be the center of our number line. -5 would be 5 marks over. 6.2, negative, 3/4, and so forth. The harder ones to handle, though, are things like radicals and numbers like pi, where we have to have a decimal approximation to locate. The TI-Nspire has a bunch of activities, so if you click on this link, it will take you out to TI's page where they will have some activities that you can do to explore this. One of the activities they have is where you set up a triangle, and this is a Pythagorean theorem. So if we have 1 squared plus 2 squared, so that would be 4 and 1 is 5, then this would turn out to be the square root of 5. So we can actually locate the square root of 5 on our number line. This is taken from the computer software version of the calculator. So again, you could go out there and explore the computer software version. Another thing that another piece that we look at is introduction to absolute value. And if the number is positive, we just drop the signs, and if the number is negative, well, in positive there's no sign to actually drop. If the number is negative, we can drop the sign. The formal definition says that if the number is greater than or equal to 0, we just write down the number. If the number is less than 0, we take the opposite of the number. So technically what this is meaning is instead of just informally dropping the sign, we're taking the opposite of a -3, which turns out to be 3. Now, this is an illustration of family. These first two will not work on the numerical TI-Nspire, but the next 3 will. So when parts of the screen will work, we label it as family, or if all the screen will work. Again, let's take a look at this on our Scratchpad. So to get back to our Scratchpad, move over to here. Click our Scratchpad. We want to clear it out. So menu, 1, 5. You're probably becoming very proficient at clearing it out yourself in there. So to get the absolute value, we will use the template button. So if we hit the template key, we can see that absolute value is over here. It's wherever we left it last. So we'll move over to this and we'll press enter. Then we want to put in the letter A. We want to move over. We want to use the with operator, or such as operator. I like to call it the with operator. So we go to control and equal, and we can see that the with operator is included in this template. And then we want A, okay, greater than or equal. So again, we're going to hit the same template, and we want greater than or equal to 0. Then we want to work the problem with A less than 0. So again, if we go up and press enter, we can copy it into history. We can go inside here, delete that one part, hit the template, hit the less than operator, press enter. Again, we do not have to be at the end, and we come up with -A. So the nice part about the CAS model is it can actually help you, if you do not remember the formal definitions, to come up with formal definitions. Again, the formal definition is given in this kind of burgundy color. Let's take a look at the absolute value of -3. So again, we'll use the template. It's already on absolute value, so we'll press enter. We'll plug in the -3 and press enter and see that the sign is dropped. To illustrate why this is true, we'll take a look at the opposite, then parentheses, then -3. Now, as earlier in this chapter, the calculator, if things aren't necessary, they will drop them. So this is helpful for understanding, but when we press enter, it drops our parentheses and just writes this out as 2 negatives. The next thing that happens is we go over creating a global one-line function. This is such an important concept that we actually have a separate video for doing this. So take a look at our separate video for how to create global one-line functions. To give you some more experience with creating one-line global functions, we have moved ahead in our tutorial series to a further volume. The further volume that we move to has to do with arithmetic functions. So it has to do with an arithmetic and an arithmetic sum, and doing the arithmetic sum 2 different ways. Okay, so let's take a look at this. So to do this, what we'll want to do is we'll want to, go to the home screen. We'll want to go to My Documents. We'll want to scroll down on My Documents to My Library. We'll we'll want to take a look at the libraries. The library for Volume 1, Computer Learning Service, library for Volume 2, which we're working on, and then some other libraries, a library for finance, some libraries that come from the manufacturer, some libraries that we wrote for arithmetic and matrix manipulations, and then we finally hit our Vols library, and if we press enter, it shows us our definition of our library and what's in this library. And if we hit control and move over to the next tab, so if we hit control and move over to the next tab, somehow or reason or other I'm having a little trouble doing that. Let's try it again. Control and move over. We see that we have these functions that are over here. And if we scroll up, we can see that we have the functions added to our libraries. Then, once we have these functions added to our library, we can use these functions. So if I go to the catalog and call up these functions, I can call up the arithmetic and function. I can call up the arithmetic sum function. I can call up the arithmetic sum 1 function. And when I'm on the CAS model, I can put in the parameters that I used to create it to come back up with the formulas. Or I can put, if I'm on either the numeric calculator or the CS calculator numerical models, I can put in the parameters and come up with the answers. This is the famous Gaussian problem where when he got in trouble, he was asked to add up the numbers from 1 to 100. So what he looked at was 1 and 100 was 101, 99 and 100, okay, 99 and 2 was 101, 98 and 3 was 101. So he took the first and the last, and there was 100 divided by 2, and then this would give him the formula. So there would be 50 pairs of 101, so the answer was turned out to be 50-50. So this is explained here in our chapter 1 explanation. Another thing that we do next is we take a look at a measuring tool, and the ratio of the distance around to the distance across turns out to be the number pi. If you take a look at the pyramids, at the time the pyramids were built, the number pi was not in existence. But what happened was they used the measuring tool to lay out the pyramids, so the number of pi occurs in various measurements. Again, for more additional details of all of this information, take a look at our ebook.